Okay, microphone on. Alrighty, good evening, my students. So this is take 2 for calculating our equilibrium constants. I had already uploaded this video earlier on and I felt very proud of myself for doing it so early, only to find out that it did not have sound. So again, this is take 2. Okay, so I'll go ahead and get straight to it. So these calculations that I'm going to be covering are going to be fairly simple. We are only going to be working with our equilibrium constant, which is K sub C. Okay, so I had posted another video yesterday where I lectured over this, but again, that one did not have sound, so I will go over that one again, or I will re-upload that one again as well. Okay, so to determine our equilibrium constant K sub C, we need to get the equilibrium concentrations of our products divided by the equilibrium concentrations of our reactants. So for number 1, all we are going to be doing, it says write the equilibrium expression for each of the following reactions. So some of this will be for homework for you guys. So I'm only going to work on letter A and letter C. Letters B and D will be homework for you. Okay, so let's go ahead and get straight to it. Okay, so my equilibrium expression, Kc, is equal to, looks like this. Okay, again, it is our products and products divided by our reactants. Okay, so our products are here on the right side of the arrow, and our reactants are here on the left side of our arrow. Let me just erase this. It's a little bit, I'm not going to have too much space to write. Okay, so one thing to remember while writing our equilibrium expressions is first to make sure that the equation is balanced. Letter A, I already double checked, is already balanced. Okay, so hold on. Getting lots of messages all of a sudden. Okay, excuse me. I lost my train of thought. Okay, so this equation is balanced, and when you are writing your equilibrium expression, you need to use your coefficients. So the coefficients are important here versus whenever we're doing our reaction rates or anything else. Okay, so let's go ahead and start by writing equilibrium expression here for part A. So my first thing I need to include is my product N204 close brackets, and then that is squared or to the second power. So the brackets are important because this is the equilibrium expression at or the equilibrium expression using the concentration at equilibrium. So we show that by using brackets. Again, those brackets mean concentration of. So in my numerator, it is my product, which is N204 in brackets, and that is raised to the second power because of the coefficient of 2. So that is divided by our reactants, products over reactants. So my two reactants are NO, close brackets, raised to the fourth power, times O2, close brackets, raised to the second power. And that's it. Just remember products over reactants, and you just need to include your coefficients, but that is it. If you're just writing equilibrium expression, that is all you need to do. Okay, let's go on to part C. Again, determine your products, which ones are your products, which ones are your reactants. These are my products. These are my reactants. Okay, so let's just write Kc is equal to, I'll something like that. Okay, let's verify that this is in fact balanced, and it is. I already double checked beforehand. Carbon and 1 carbon, perfect. 1 oxygen, perfect. 2 times 2 is 4 hydrogens here. 3 plus 1, 4 hydrogens here. So it is balanced. So the only one that has a coefficient is our hydrogen gas in our reactant side. Okay, let's go ahead and start writing. Again, products over reactants. So it is CH3OH, close bracket, that's my product, divided by my reactant, CO, close brackets, times H2, close brackets, squared, again, due to the coefficient. Okay, so that is it for number 1. All you need to do is write the expression, products over reactants, that's all you need to remember for that. No plugging and solving yet. Okay, but I will go on to number 3. In number 3, there is some solving taking place. Okay, so number 3 says, a container at equilibrium contains the following concentrations. It says hydrogen is equal to 0.30 molar and HI is equal to 0.90 molar. The equilibrium constant is equal to 6.0. What is the concentration of I2 at equilibrium? So we've got a lot of information here. First, it's giving us our equilibrium concentrations, okay, for 2 of the substances in this reaction. And it gives us the equilibrium constant. We are looking for an unknown concentration of I2. So whenever I am solving this, my first step is to write my equilibrium expression for this reaction. Okay, so we got some news as teachers and there's some confusion with this, so that's why everybody's going back and forth asking questions. Okay. So let's start with our equilibrium expression. Kc is equal to, it looks like that. Okay, so again, products over reactants, this equation is balanced. So on top, we have Hi, close brackets, squared, times H2, close brackets, times I2. Since they do not have any coefficients, they do not need any exponents. So one thing I do want you to know, students, don't get confused with coefficients versus subscripts. Coefficients are these big numbers in front. That is what becomes your exponent. The subscript is part of the chemical equation. So H2, that subscript telling us we have 2 atoms of hydrogen. So do not forget to be writing those. Okay. So now that we have our equilibrium expression, we can start filling it in with the actual, numerical values. Okay. So Hi, it tells us, has an equilibrium concentration of 0.90. Okay, 0.90 squared times, I guess I need to include the little m, molar, excuse me, times H2, which has a concentration of 0.30 molar, times the concentration of I2, which I do not know, so it is just going to be replaced with an X. Okay, and then we know the equilibrium constant is equal to 6.0. Okay, so my first step to solving for x is to move whatever is in my denominator to the other side. Okay, so I do that by multiplying both sides by the reciprocal, which is 0.30x. Okay, so times 0.30x, so that cancels out here, times 0.30x. Okay, so what it looks like when I write it down into the next line, I have 0.90 squared is equal to 6.0 times 0.30x. Okay, so let's go ahead and start simplifying this and solving this a little bit. So 0.90 squared, I have a calculator right next door to me. I suggest that you guys fill this or follow along and solve these or do these calculations yourself as well. That way you can see where I'm getting these values from. So 0.90 squared is equal to 0.81. That is equal to, so now I just need to distribute that, 6.0 times 0.3, which is equal to 1.8x. I'm just getting a ridiculous amount. Okay, sorry guys. Just got a lot of messages all at once. So I want to make sure everything was good. All right, so to solve for x, right now it is being multiplied by 1.8. I don't want that 1.8 there. I need to move it to the other side in order to get x by itself. So we're going to divide both sides by by 1.8. Over here, divided by 1.8. Okay, cancels out here. So then I have 0.81 divided by 1.8. Okay, so when I do that, I have x is equal to 0.45. All right, so let's just go ahead and write this a little bit cleaner. I'll change my ink color. So I can say the concentration of I2 is equal to 0.45 molar. Okay, and that is your answer here. Here you go. Okay, so hopefully that helps you guys a little bit. Again, let me know if you have any questions over these types of problems, and I'll go ahead and continue on to the next one so I don't make this video too long. Okay, so then number 4 is going to be very similar, and number 5 and 6 are using the ice or rice tables. Okay, so number 6 involves the use of the quadratic equation, quadratic formula. However, I'm going to show you a slightly alternate way that you can do things. It is not going to give you an exact answer, but if push comes to shove, it will give you a slight approximation. Okay, so I'm going to solve number 6 for you, and then you're going to be responsible for solving number 5. Number 5 is a lot simpler. Number 5 does not use quadratic equation or anything like that. Number 5, you're going to solve it similar to the way I solved the one in the lecture yesterday, which again I will have to redo and re-upload. But okay, let's get straight to it. It says, okay, so it says I have 0.5 moles of COBr2 is added to a 2-liter flask. What are the equilibrium concentrations of each species, having an equilibrium constant equal to 0.19? Okay, so first thing, I have our reaction. Someone's right outside my window talking. Need to get my dogs inside too. Okay, so I have 0.5 moles in a 2-liter flask. So one thing to remember, students, is that your concentration is your moles per liter. Since that is moles in 1 liter of solution, Here I have 2 liters, so I just need to divide that 0.5 by 2 in order to get the new concentration, which is 0.25. So the initial concentration of COBr2 is 0.25 molar. The initial concentration of my 2 reactants is going to be 0, 0. Okay, so then looking at the change, I don't know by how much this is changing, but I do know the reactant concentration is going to decrease by some value x, and my product concentration is going to increase by some value x. Okay, so then once it reaches equilibrium, this is 0.25 minus x. This will just be 0 plus x, which is x, and again 0 plus x, which is x. Okay, so to get straight into doing the calculations, my first step is always to come up with our equilibrium expression. So I have Kc is equal to, again, products over reactants. This equation is already balanced, so I do not need to worry about any exponents here. Okay, so on top, my 2 products, which is CO and Br2. I don't know why I wrote it so silly looking there. Divided by my reactant, which is COBr2. Okay, so now we just need to fill this in, or start by filling this in with the values at equilibrium. Since Kc is our equilibrium constant, the concentrations have to also be at equilibrium. Okay, so let's go ahead and fill this in. So both CO and Br2 have a concentration of x. So it'll be x times x divided by COBr2, which has a concentration of 0.25 minus x. And all of that is equal to 0.19. I got that here from the question. So, again, there are 2 ways to solve this. The correct way is by using the quadratic equation. However, on this year's AP exam, they have already released one, that you're only going to have a total of 45 minutes to take the exam. 2, it is not going to require heavy calculations. And 3, I just don't think that they're going to ask one of these questions because they want to test as many concepts as possible. So if they do ask an equilibrium question, my guess is it's going to be more conceptual than calculation based. So I'm going to show you the way that you can, what is the word I'm looking for? Estimate the answer. It is not going to be the exact correct answer, but I will post another video, I'm guessing sometime tomorrow, since I have to remake all these, on how you would answer this by using the quadratic equation. Is it equation or formula? I always get it mixed up, but you know what I'm talking about. Okay, so the way you would do this, since we have a very small Kc value, since we're dealing with decimals, 0.25, 0.19, we can stand to reason that our x is also going to be a small decimal value. Excuse me. So since it is going to be a small decimal value, we are going to assume that the value in my denominator is going to stay something similar to 0.25, whether I subtract x or not. So I'm just going to take off that x. So it is just going to be x times x, which is x squared, divided by 0.25 is equal to 0.19. So this is a much easier equation to calculate. No need to use quadratic formula here. Okay, so just like before, I want us to move that 0.25 from the denominator, so multiply by 0.25 to both sides. Cancels here. So I have x squared is equal to, and then here 0.19 times 0.25, 0.05 475. Take the square root of both sides, second square root, second answer. So I get my x is equal to 0.2179. So I can round it to 218. So one thing to look for to make sure that your x value is correct is once you plug this x value in back into this equation here, you cannot end up with a negative concentration. So this x value has to be less than whatever concentration you are starting with. So we got a concentration or an x value of 0.218, which is less than the 0.25. So that means we did this calculation correctly. Although we estimated a lot, so again, this will not be the 100% true correct answer, but we at least didn't get a negative concentration, so that means we are on the right track. This is mostly done with calculating your equilibrium constants, your Ka, Kb for your acids and bases, but that section was scrapped from this year's AP exam, so I'm just applying this similar method here. But okay, let's go ahead and continue. So I have my x value of 0.218. I'm going to move up here to do the remainder of my calculations. Okay, so to find all three equilibrium concentrations, I have CO Br2 is equal to 0.25 minus x, and x is 0.218. So then I have 0.25 minus 0.218. So I get 0.032 molar. Okay. For CO and Br2 is equal to just x. So it is just equal to 0.218 molar. And again, Br2 is also equal to just x, so that is also equal to 0.218 molar. Okay, so that is how you solve these. And there you go. Okay, so I hope this was helpful for you, my students. Now it has sound, so again, I will re-upload this to help you with your next assignment. Okay, if you have any questions, comments, concerns, please email me. My email address, I'll write it here, is m.valdez10@ljist.com. So you can contact me there if you have the app Google Hangouts. Okay, you can send me a quick message. I will be hosting a question and answer session sometime tomorrow, which is Thursday, which is, I believe, April 30th from 3 to 4 p.m. I will be covering this same topic, equilibrium, and I will be giving you some updates on the AP exam. So please try to attend. Okay, I know this is a little bit late and I'm sorry, but I hope this helps you, my students. And that'll be it.